Actually, hold on. Let me stop that. Oh, it's cloud recording. That's cool. That's fine. That works. Um, yeah. So anyhow, like when you have this here, like say that's one, that's like seven. Yeah, that's what this means. It turns this on number line. I mean, that's pretty easy. Or an XY graph. If I have like 1, 2, and then off to the yonder, I have like 4, 6. Do you guys know how to find those 2 points? What can you do? If you use some intuition, what can I do here, guys? Or Pythagorean theorem.
Oh,
That's 3 and 4. I mean, it's actually pretty easy for you guys. Holland's hypotenuse. Boom. There you go. Right? So that's not that bad. We already did the always, sometimes, never questions. Yeah. So anyway, these are. So if you're curious what the quiz is on, that's it, guys. And we're getting some practice on it today. That's the quiz. But of course, we want to just go a little deeper. So let's see here. Kayla, do you mind reading practice number 2?
Theorems, figures in order to solve algebraic equations. Interpret postulates and theorems that represent existence in uniqueness as it pertains to points, lines, planes, and space.
So what does that mean? Well, that means that angle addition postulate. Two angles add up to a bigger angle. Definition angle bisector. So some ray cuts an angle in half, right? And then connecting that geometric concept to the algebra, right? That's precisely what you guys did in this homework, right? You guys did that precisely. So when you look at practice number 2, you're doing it. That was number 4 and 5. That's practice number 2. So you're totally living that reality. That's awesome. That's what we want, right? That's the whole point of this stuff, right? So, yeah. So that's all it means. Okay, practice number 3. Zoe, can you read that part, please?
Explain the difference between collinear and non-collinear. Explain the difference between collinear and non-collinear. Despite collinear points on an XY graph using slopes, verify graphical intersections on a figure or graph algebraically. Explain the difference between a postulate and a theorem.
No, I won't probably ask that fifth item on the quiz because that's going to be more for the second unit. But we know a postulate is like anything that can assume to be true. Theorems have to be proven. But we did talk about collinear. What does it mean for 3 points to be collinear? They're all, yeah, go James. Or both James, yeah. They're all on the same line. The other James, how non-collinear?
they're not all on the same line.
How would you prove it?
By drawing a line
Yeah.
to the points.
And mathematically, what formula can we use to compute between the points? So it's an S, 5 letters. Go, Kale. Slope, exactly, yeah. So like when it says the third bullet point, justify, how do you justify? You draw a slope. Or you calculate it, right? So yeah, and that one I might ask. I kind of like that one because that's a good way to test. Because do usually the way I like to write questions, I like to have like 3 or 4 different topics covered in one question. And that's a great question. Where if I just give you 3 points, I say, hey, find me the slopes for these 3 points and tell me if they're collinear. I'm knocking out two things there: slope and, of course, collinearity, right? So, yeah, good.
How many questions should be like?
Kyle, right? Yes. Sorry, I was gonna call your name, but yeah, go. Kyle. How many questions? I don't know yet. Probably I'm thinking about 4 because my tests are usually 10 questions. Yeah, usually they're 10, 9 to 10. So a quiz would be shorter, probably about 3 or 4. Yeah, probably just a couple pages and probably something. Okay, I'm gonna brag a little bit. Uh, so I have to do the test first before I give it to you guys. My rule is times 6. What that means that however long it takes me should take you times 6. So if it's a 1 hour test, usually I do 1 hour test in 10 minutes.
What?
Yeah, well, I wrote it. I know you do. No, I wrote it and I know the answer key. But what it means is that that's the calibration I do, right? Because I know I'm going to process more quickly because I know the test and I've written it. So that's why I do times 6 to be fair to you guys, so that I can expect. And it's a rule that's worked wonders for 22 years. So I'm not going to stray from that. That's good.
So 4 hour, or sorry, a 4 question test is gonna take an hour.
No, no, 4 question quiz should take about 15 minutes.
Oh.
So I should be able to do it in 2.5 to 3 minutes. So I do it really fast and it's good for you guys. James, good.
For example, like a
I know I'm bragging, sorry, but
10
yeah.
question test, that like one, A, B, C, D, E.
Mm. You know, I'm gonna do that for you and that no one else. Yeah, just kidding. No, yes and no. It depends. I mean, it's no, I don't do it for all the questions. I mean, it just depends. Um, but I know what you mean. Like, no, I'm not. It's not gonna be like that crazy. Don't worry about that. But occasionally, sure. Ishan, go ahead.
In a hypothetical scenario, what if you take 20 minutes on finishing your own thing?
So I have a little leeway with quizzes for the most part. Tests, I do have to be a little bit tougher. Now, if you do have extended time, of course, I'll grant that to you, or you could do an ASC if you have. I don't know. I can't remember who has extended time in this room. I have to look at the roster, but the test, I'm usually we have to kind of adhere to it because I'm not doing you a favor if I continue giving extensions because then when you move on to your next class next year and the year after, that's the expectation. You have to get these tests done within the time frame. But that's why I calibrate it though. I do my best to calibrate it so that you don't have to feel that need. And of course, if that's gonna be if it is a continuing issue, then we could have another conversation, right? Then we'll get the advisor involved. But let's not worry about that. I think you guys will be fine. Kyle, go ahead.
When should we expect things to like start going crazy?
Oh, probably the next day. Yeah, I'm also the other thing too. I'm also the fastest grader on this campus. Actually, I was in the yearbook the fastest grader. So, yeah, I know I'm bragging. I'm sorry. I'll keep my ego in check. I'm not perfect. I make a lot of mistakes too. No, but I try to do things quickly. No, the reason why is because I want you guys to get the immediate feedback while it's fresh in your head. Like I despise like, oh, I took this test 2 weeks ago, now I finally got the test back. Like that's lame. I want to tell you right away. So if you need to correct things, like if you need like self-correct and this and that, yeah, go ahead. But the homework is just completion. I haven't put it there yet, but I will fairly soon. So yeah, so no worries. Yeah, good. Yeah, just really pack. We're gonna get started very shortly. We're gonna do some practice problems. Yeah, good.
Yes.
You should. Yeah, if you haven't yet, honestly, I'm giving grace period this week. Don't 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 worry about it. And Sam, right? And Galila, right? Yeah, yeah. James?
You take your 10-minute test, do you get questions wrong?
No,
Have you ever?
I really miss. Yeah. I mean, okay, occasionally, rarely. I mean, like, so, well, I will say this. I do it a second time also. I do it a second time, but I do it more neatly, where I actually make my answer key. And then actually, I will deliberately try to grade the person in the class who is probably the strongest. I don't know who the strongest student is yet, but occasionally I will know who the strongest student is. And then I check it with them. And then also I do check with the colleague too. So I actually do it 4 or 5 times. So it usually is pretty rock solid. So yeah. Okay, let's last one. Practice number 4. Lisa, can you read the practice number 4? Yeah.
Define space segments and ways. Geometric objects above using correct notation. Define postulate, theorem, fluid postulate, distance segment, addition postulate, congruence, midpoint segment, bisector, angle, protractor postulate, angle, addition postulate, congruent angles, adjacent the angle bisector. Indicate the geometric objects above using correct notation. Identify the characteristics of the equivalent in quadrants, quadrant, phase, equal, axis, and origin. Interpret so as positive, negative, zero, and 100.
Cool. Yeah. So I mean that's what's going on there. You guys should be able to communicate what it means to have a positive and negative slope. I mean, you should know what the postulates mean. I'm not going to necessarily quiz you on this stuff, but it's more just like the notation, like knowing how to draw things correctly. We care about that. And interpreting, like, hey, that's a ray, that's a line, that's a segment, so forth. So, all right, I think now what we want to do is start doing some practice. So, what I want you guys to do in your table groups is just write these things out, kind of in your own words, share. I'll also do the same myself, and I'll share every few minutes. So we're gonna go through this, go through that, go through that, do a little more, and then afterwards, you guys will work on this. This right here is a review for the quiz. Expect the quiz to look like this. Not this long, by the way. Not this long. And the answer keys provide as well. But we're going to get there in about 15 or 20 minutes from now. For now, let's just handle this stuff. So again, just try to answer in your own words. I'm going to do the same. I'm going to freeze the screen. We'll share in about a few minutes. Do this in your table groups, talk to each other, I'll walk around. And I'm going to do this on my own right now.
You were bigger than us.
Yeah.
Go right for the X. We're counting back.
Yeah, say what? It is, yes. For the first question, I know it's kind of a dumb question. Just say locate X and Y. Yeah, it's a dumb question. I think it's kind of dumb.
Oh, wait, that's that. I can get. They have. Yeah, 5,000. Yeah, what's not that? There's a lot of these.
I think it's just like, what you work focusing on.
You grab the line, you write down usually something, so those line, they can go to line, how to do it.
That's a little.
So the line is.
That's like, yeah, X one, we said, or no, let's say X one minus.
Y is five times.
M.
No, equals M times X minus.
Or you just. Value. You subtract is Y minus one, you say.
So, using slump as. How do you spread only for those things? How do you? What is the ratio? You made them like, yeah. Elimination section.
A point to this, that's ratio.
A point is just one dimensional.
Correct, right. One special object.
In a relationship between two numbers.
Is it perfect?
It must be after.
No.
Oh, graphically, you're just like,
So for calculating.
where they intersect.
Can you grab the word?
So it's just really the make you two doing that.
It's not, wait, should we write this down for the points?
Sure.
Y one, Y minus Y. And that's the point, you do this. That's. Yes, that's how you do points. Why not that one?
There's a sketch.
Is a point one dimension?
That's like 2 months.
Oh, I have the answer right here, guys. A point.
A point is 0 dimension.
Yeah.
Oh, it's zero
Yeah, that's what it
dimension.
says.
I think we'll leave it a lot of posts on.
How do you describe something? That there was.
Y minus one is M times.
What is that? Oh, just right.
Yeah.
Is this graded?
This is not great now. I mean, we are gonna do a review set afterwards. That'll count as homework, but I'll watch you guys do it, so you don't have to upload it. Okay, so far, how do you plot points on a coordinate plan? A coordinate plane, that's a typo. Just look at X and Y. X is horizontal, Y is vertical, these right. Change y over change in x. You could write it as rise or run, or we want y2 minus y1 or x2 minus x1. I don't care. But just bottom line is you have to, take a ratio of the changes of y and x. How do you determine if points are collinear? You got to find the slope. How do you plot? How do you graph a line? Usually helps to start with the y-intercept and then use the slope to get the second point. Or if it's in point slope form, that's point slope form. You'll be given a point anyway, right? X1 and Y1 and use the slope to get the second point. Obviously, how do you find the intersections where they meet? A ratio is just a division situation. You're dividing two things. For example, if you're talking about like shooting percentage, like I know like Steph Curry has like say 20 shot attempts, makes 10 of them. You shot 50%. That's a ratio, right? Just dividing two things. A dot or one-dimensional object, that's a point. That's slope-intercept form.
It's 5 minus 5, 1 equals that.
But it's good to recognize that. A line is an infinite set of points, and they go forever in both directions. Remember, line segment has endpoints, though. It's still an infinite set of points, but just has endpoints, right? And of course, we'll keep on going. Pythagorean theorem. Yeah, so what you do is you plot the two dots, and then you connect them, and you want to find the length of that segment. Usually, the best approach is just to do Pythagorean theorem: a squared plus b squared equals c squared. You could also do this too. There's a formula that's called the distance formula. I'm not sure if you guys seen this before. Have you guys seen that?
Yeah.
Some have, some have not. But really, all it is a glorified Pythagorean theorem. That's all it is. Because if you think about you're squaring two distances and adding them up, which is what Pythagorean theorem is all about, and you're isolating the hypotenuse. That's all you're doing. So it's just a glorified Pythagorean theorem. That's all it ever is. Okay, go ahead and do the bottom part. I'll do it as well. We'll check in about a couple of minutes. So I'm going to, I'll leave the screen frozen here so if you guys are still copying. So a line looks like this. That's a notation. Yeah, some of these don't have notations though, so don't worry so much about that. Yeah, good. What? Sorry? Three-dimensional set of points.
What's a line? It's a line and then you add the line.
It only goes one way.
It's a lot.
Yeah.
He said a point is a one-dimensional object. This is a plane. And then two-dimensional is like you add like that, and then a plane is not made. That is like not made of a line. Not even mentioned.
Yeah, keep it simple, guys. A plane is a two-dimensional set of points. So it also, I mean, there are other ways of understanding it. Like, for example, a point in a line could fall on a plane, or two intersecting lines can be put on a plane. But at its core definition, it's just a set of two-dimensional set of points, like a piece of paper or the table in front of you, right? Space is the same definition, just change a 2 to a 3. So like a box, or that trash can, or this room. Collinear, points in the same line. Obviously, 2 points are always collinear. But to have 3 or more points collinear, they'd have to have the same slope. It's a little more challenging to get that to happen. Non-collinear, obviously points not in the same line. So if you have like 3 points and not all 3 of them are on the same line, then it's not collinear. So what's the
difference between a plane and a space?
Space is 3 dimensions. So like basically like a box. Like take
that volume inside.
Volume. Yeah, volume and area. That's a great way of putting it. Volume and area. Where plane, you find like I can find the area of that piece of paper, just take the length and width, like it's 8.5 by 11, so whatever that area is. But dimensions involve length, width, and height. We're doing volume. Okay. Let's keep on moving to the next page. All these frozen here. I'm gonna define more stuff.
Or like the definition, the basic of that.
No, no, I mean, I might throw in like a true or false question. So you should like, if I say true or false, are for 3 points to be collinear, they have to have the same slope. Like you kind of need to know that. Like I'm not gonna ask you to cite the definition, but you gotta be aware of it so you can apply it for a question. All right, so why don't you guys try the next page? I'm gonna write up my answers in a moment.
We'll have to walk around the room, right?
Sure, if you want. Go ahead.
We're two lines. Yeah, we're like, we're chipping the big rock. Yeah.
The line with.
Yeah, right. Well, 2 points will always be on the same plane, but if you have four more points, or like maybe 2 points in a line, right? But it's when you have multiple points, they're not on the same plane, like several. Oh, hold on, give me a sec here.
Yep. The middle of the sat.
Yeah. Wait, it's like, it's an infinite line. So, yeah, it won't have a midpoint then.
I did.
I think we want segments. Segment by segment.
Aren't lines technically always congruent?
Yeah. Yeah, sure.
They're infinite.
Oh, yeah.
Whit, I'll be with you in a moment. You had a question. You had a question, Whit, right? Give me a sec. Hold on.
Definition is a line that splits an angle.
Okay. That's more stuff for you guys. Non-complainer will be definitely. That would be not how five those points.
Right next to each other.
That points like off the plane. Yeah, you gotta think with three dimensionals, kind of like, let's say I've got a bunch of like, you have a whole bunch of these sauce, right? But let's say I go grab the box and grab the trash and grab like just a whole bunch of stuff. But then look at those whole bunches that floating up the air. Then that's not all fill plan, because some are on the table, so we're not on the table. So if you have any points that are not on the table, then some are, then all those points are not fill plan. Just like ones that, so you have to think in three dimensions, that's probably why I started with this. Yeah, making sure you want.
Just like a distance.
You can also be, three and fifth lines. Yeah, or just three lines. And then, any two lines can be put on a plane. Well, actually, no, I take it back, there's something called skew. But, yeah, if you have a three or more lines, that's possible. Three lines. Or you can, say, point and.
Oh, yeah.
One line's one line.
So 5 minutes.
Points in a line.
Think so.
No, so what's the second? The point has to. We have to. Otherwise, because one against one like. I grew it, you should feel like. Okay, looks like you guys are getting ahead, which is fantastic. You guys make great progress. We're at coplanar, all points are lines on the same plane, but it's just the opposite. Points and lines not on the same plane is not coplanar. Intersections is what's common. They don't have to be a single point. Like for two lines, of course, a single point, but for two planes, that would be a line. A line would be common between two planes, and a line is an infinite set of points. So I'm not wrong in saying that when I call points. Segment is an infinite set of collinear points, just like a line, but there's two endpoints. Array is like a segment has one endpoint, goes for one direction. Opposite arrays, they share the same endpoint, but go opposite direction. Postulate is a mathematical statement that is always assumed to be true. So hopefully that makes sense. What's the good?
How does an opposite have the same influence?
So it looks like this. Let's go red so it stands out. There you go. So let's say that's A. That's B. And that's C. So ray AB and ray AC are opposite rays.
Wait, add like another point to the line.
Add another
If
point?
you had like a D next to D. And
No,
then it was
okay. Like that?
Yeah, if it was DB and then CA, is that?
No, because they overlap. They can't. The only thing they have in common is an endpoint. That's it. That's the only thing they have in common. They cannot overlap. So just the overlapping rays. Yeah, just. But opposite rays have just. Yeah, let me rephrase that. Two rays with the same endpoint. And actually, technically, what you were just describing wouldn't be the same endpoint. Like if I had like CB and DC, they don't share the same endpoint, obviously. So yeah, so going opposite directions, they don't share an endpoint. So they have to share an endpoint. Kyle, go ahead.
Line that goes through a plane intersects that, like, where does it intersect?
Point. Yep. All right. Let me freeze that. If you're still simmering on this, I'm gonna keep going. A mathematical statement. I have right there. These are right there. Yeah. Definition of postulate. Oh, it's just where you locate angles. Don't worry about that. Oh, hold on, wait.
Oh.
Give me a sec, wait.
Which is a lot too. No, at least, at least somehow. Like, really, this is a
What's the role of posture?
Oh, actually, I heard you do best about that.
Okay, here's the next one. What was the question?
Oh, so you never worked on this before, so like 2 points on You're a little ahead, that's all this. Oh, so let's wait, let's hold on, yeah. Yeah, so just hold on. Okay,
Okay, so looks like people are getting a little ahead, which is good. Definition congruent, two objects the same shape and size. Hopefully you guys are okay with that. Definition midpoint halfway between 2 points. Object that can cut a segment in half is definition segment bisector. Angle bisector cut an angle in half. When I say an object, it could be a ray, line, or segment itself. Adjacent angles, two angles next to each other. They share the vertex, they share a side, there's no overlap. So hopefully we're okay with that. I know you guys are getting a little ahead, so let me do this a little more quickly. Acute angle, less than 90 degrees, equal to 90 degrees, greater than 90 degrees, equals 180 degrees. Boom, boom, boom. Okay, that's done. We're good. Ruler postulate, honestly, I don't care about that. It's like, I honestly don't care about it. Second addition postulate, two smaller segments that add to a big segment. That I do care about. Okay. Protractor postulate again, just cross it off. I don't care about it. All right. Angle addition postulate, two smaller angles that add to a bigger angle. Okay. So we got that. Okay, and I think some of you guys are stuck on this. So let's wrap this up. 2 points determine a line. Okay, hopefully you guys know that. At least how many points does the line have? 2. Name 3 ways to determine a unique plane. 3 points. 2 lines. Or a point and a line. So that could be like when I'm thinking of the quiz, I mean, I'm kind of thinking about it right now, like it's like that second question on homework 4, those always sometimes never questions.
Oh, okay.
Yeah, I might do something like that, like maybe like 5 or 6 parts. Like it'd be one question, it'd be 5, 6 statements, and you gotta tell me that. So
So.
and it'll be kind of like this, kind of like
It'll just be 4 really big questions, pretty much, that just cover like a bunch of things.
correct, right. That's probably, and like I'll probably give you like a bunch of like lines, arrays, and angles, and like
How many points will the whole thing?
somewhere probably 15, 20 points. Yeah, that's what I'm probably thinking. Same for
What is the unique point?
where does it say that?
No, it's like part of the question.
Maybe.
Like,
It's just a plane in general. That's all. Yeah, that's all. Because that would be because the plane would be unique to those 3 points. So you have 3 dots, and you're putting a plane on that, and no other plane can have those three dots. That's why it's called unique, because no other plane could do that.
okay.
That's why. Sure, yeah. Any 2-dimensional shape. Plane contains at least how many points? Yeah, go ahead, Dave. Yeah.
Letter on 3.
Points and it's an and symbol. My apologies. I struggle for writing that. A plane contains at least how many points? 3. Space has 4. 2 lines intersect at a point. 2 planes intersect at a line. 3 planes intersect actually, hold on, 3 planes? How would you say that? 3 planes intersect. They could intersect at a line. They could. You know what? Let's not worry about that one. Let's cross that one off because I don't like it. I don't know what the answer is. So I'm not no, well, it's not I don't have a straight answer because it could intersect in a line, but it could also intersect in a set of lines. And so it's too ambiguous for me. That's why I don't like it. I don't like that question. A line that goes through a plane intersects a plane at a point. Yeah, because 3 planes, again, they could intersect at a line, but they don't have to. That's the thing. Like they could intersect, like the intersection could be space. Not space, but actually, no, if you think about it, if they do all intersect, sorry, you know what? No, I could answer that question. I could. I'm overthinking this one. I still don't like it, but it is a line still. If all 3 of them are intersecting, it would still be a line. I just don't like that question. Okay, we're good. No, because if you take 3 pieces of paper, you create creases in them, and like kind of like slip them together. The crease is actually a line. So if it's a 3 plane, I mean, it's kind of hard. I'd have to. I'll do this. If I were to,
What's the intuition from?
it's really tricky. Okay, so I like plane cut in half, right? Okay. It's very flimsy. So let's see right now, these are 2 planes that intersect. The crease where they intersect, that's a line. I could bring in, this is really hard for me to do. It's so flimsy. I got the hardwoods off. But if I brought in a 3rd plane and did the same thing, they have to intersect where those creases are. So they're all intersecting the same line. So that's what's happening. Yeah. Yeah, but then not all 3 of them are touching the same place though. They're all you want all 3.
one on top, side and one line.
That's still a line.
But yeah,
Well, it's just wherever the lines in common of all 3 planes. You want to try drawing for me? So I could, yeah. Okay, so at least good. Yeah, of course, yeah. So now, no. I'm not playing music for you guys. We could do that tomorrow if you want. Now what I want you guys to do is work on this review. This is homework. So this is counts as homework. And we have still got another 10 or so minutes. So I'm gonna call this homework number 3. And yeah, actually I'll have you guys upload this because it's still good to have the record of it.
okay,
But this will count as homework. So this is your preparation for the quiz tomorrow. And we'll go over this in class tomorrow too. 100%. And we also have office hours tomorrow, but go through this. You do have the now this is you have the Ansky. The Ansky is at the end. We do. It's actually the second right after the first period. So yeah, so work on the rest of this here. This is excellent practice for the quiz tomorrow.
So
And that's that.
these 3, it's a box. And
Well, let me stop recording.
so this is homework. This.
It is, yes.